In our lab tomorrow, we'll be dealing with sodium hydroxide, NaOH. We need a concentration for the lab of 0.3 moles over liters. And I needed to prepare approximately 3.5 liters to have enough solution for all four of our classes. And the only problem was that I didn't have 0.3 molar solution in the cabinet. So I needed to go ahead and find a higher concentration to dilute so that we would have enough of the solution in the end. So I needed to calculate what I would need. It's easier for me to measure my volumes in milliliters because that's what my volumetric flasks are, that's what my graduated cylinders are. So my final answer I want in milliliters. So I know that I want a concentration of 0.3 molar. I want to have 3.5 liters of that total, and I want to dilute it from my volume that I had of, or my molarity of NaOH that I had to start which was 6.0 moles over liters. That's how I get it from the chemical factory. So 6 moles per liter of NaOH that I have initially. So C1V1 is equal to C2V2, or another way of writing that is the molarity of NaOH for the first one times the volume of NaOH is equal to the molarity of NaOH times the volume of NaOH. So I can just start plugging in my numbers, or I could rearrange first. Either way, I know that I'm looking for one of my volumes. So I can rearrange, or again, plug in first. I'm going to plug in first this time. I have 0.3 moles over liters multiplied by 3.5 liters equal to 6.0 moles over liters multiplied by my unknown volume that I'm looking for. So I can take my 0.3 multiplied by 3.5. I get 1.05 moles equal to 6.0 moles over liters multiplied by my volume of NaOH. Well, if I want to get my volume by itself, I need to divide both sides by 6.0 moles over liters. So moles over liters and the 6.0 cancel out on this side. On this side, I have to do the same thing, 6.0 moles over liters. My moles cancel out. I have 1 over liters, which means I have a unit of liters in the end. And I take 1.05, divide it by 6, and I get 0.175 liters of NaOH that I start with and then dilute to a total of 3.5 liters. Well, again, it's hard for me to mass this out this way, so I need to figure out my volume in milliliters, which just means I need to multiply by 1,000, which also just means I need to move my decimal place 3 times to the right. So this is 175 milliliters of NaOH that I have to add 3.5 liters of water to, or approximately 3.5, until I have that total volume. Well, I haven't looked at sig figs at all with this one. Based off of my initial molarity of the actual volume molarity of NaOH that I want, I just need 1 sig fig. So I could theoretically round this off to 200 milliliters of NaOH. I want to be as precise as I can with the equipment that I have though, so I would probably shoot for this 175 milliliters. So again, what this is saying is I'm measuring out in my graduated cylinder an initial volume of my 6 molar NaOH at 175 milliliters. I'm going to put that into a volumetric flask that tells me at this point I'm at 3.5 liters. I'm going to add this to it and then add water to top it off. And then what I have in this beaker is now 0.3 molar.